We are about to pull back the curtain on the digital world. We're going to look at something that happens billions of times a second but is totally invisible. The secret conversations happening between all the different pieces of software we use every day. So, let's dive right in.
Really think about that for a second. You open an app and bam, your photos, your messages, your entire profile, it's all just there, instantly. It feels like absolute magic, right? But it's not. It's actually a super high-speed, very structured conversation happening between your phone and some computer thousands of miles away.
And just like any conversation we might have, there are different styles. Sometimes you need a direct back-and-forth chat. Other times, you just want to send a quick text and know it'll get there eventually. In the software world, these rules of conversation are what we call communication patterns.
Okay, first up, let's talk about the most direct way apps can talk to each other, the synchronous call. The absolute best way to think about this is like making a phone call. You dial, you wait for the other person to pick up, you have your conversation, and you can't really do anything else until you hang up that phone. The classic example of this is something called a remote procedure call, or RPC for short. And the goal of RPC is honestly brilliant in its simplicity. It tries to make a function that's running on a server thousands of miles away look and feel exactly like a function running right here on your own machine. It just hides all the messy network details from the developer.
So what's the catch? Well, that's what's so interesting here. The big pro is simplicity. It's super straightforward for a developer to write. But the huge con is that it's blocking. Just like that phone call, your app is literally stuck waiting for a response. If the server is slow, your app is slow. It also creates this really tight link, or coupling, between the two systems, which can make things fragile.
Now, a very close cousin to RPC is RMI, which stands for Remote Method Invocation. Just think of this as RPC, but built from the ground up specifically for the Java programming language. So instead of calling some generic function, you're calling a specific method on a Java object that's running in its own little world, what's called a JVM, that just happens to live on a totally different machine.
So the crucial thing to understand here is specialization. RMI is incredibly powerful if your entire world is built with Java, but its greatest strength is also its biggest weakness. It's totally Java-specific, and that makes it pretty much a non-starter in today's world where systems are built with all sorts of different languages.
So where do we actually see these direct calls in the wild? Oh, they're everywhere. That moment your app loads your profile, that's probably an RPC-style call. Or when one internal service inside a company needs a quick, specific answer from another one. That's a perfect use case. It's for when you absolutely need an answer and you need it right now. And this brings us to a really important distinction. The phone call we've been talking about is what we call synchronous. You're stuck waiting. But what if you don't want to wait? Well, that brings us to the text message model, asynchronous communication. You fire off your request, put your phone in your pocket, and get on with your life. You'll deal with the reply whenever it shows up.
All right, so let's explore this whole text message model. Let's see how it can help us build more flexible and resilient systems. This is the world of asynchronous patterns, where we're not making direct calls anymore. Instead, we're sending messages and just trusting a system to handle the delivery for us.
Probably the most common way to do this is with message passing. So instead of applications talking directly to each other, they drop messages off at a kind of digital post office, which is known as a message broker. They don't need to know who's going to pick up that message or even when. They just drop it off and trust the system.
And this shows you exactly how it works. It's brilliant. An application, which we call a producer, sends a message to a specific list or a queue. The message broker, that digital post office, holds onto it safely. Then sometime later, could be a second, could be an hour, another application, the consumer, comes along and picks up that message whenever it's ready to handle it. The producer and consumer never even have to be online at the same time.
Now, a really popular flavor of this is the publish-subscribe pattern, or just pub-sub. The best analogy for this is subscribing to a magazine or a news channel on YouTube. A publisher sends out a message to a specific topic, like sports scores. Then anyone or any service that has subscribed to that topic gets a copy of the message. The publisher has no idea who's listening, and frankly, it doesn't care.
The huge, massive win here is decoupling. These systems are completely independent of each other. You can add 1,000 new subscribers, and the publisher never has to change a thing. This makes your systems incredibly scalable and resilient to failures. The downside? Well, it adds complexity. You now have this message broker system to manage, and you have to be okay with the fact that messages won't be processed instantly.
So where does this approach really shine? Think about an e-commerce website. When you click Place Order, you get an immediate thank you page. You don't have to sit there and wait for your credit card to be processed, for the shipping label to be printed, and for the inventory to be updated. Nope. All of that stuff happens in the background, kicked off by a series of asynchronous messages.
Okay, now, there's one style of communication that has become so unbelievably dominant that it really deserves its own category, and that is REST. You've probably heard of it. It's essentially the universal language of the public internet.
You want to know the secret to REST's success? It didn't invent a bunch of new, complicated rules. It just uses the exact same language that your web browser uses every single day to fetch websites, HTTP. By piggybacking on the foundational protocol of the entire web, it became instantly understandable to pretty much any programming language or platform on Earth.
So the most important word for REST is interoperability. It's the ultimate works-with-anything solution, which is exactly why it powers almost every public API you've ever used. The trade-off is that it can be a little chatty, meaning it uses human-readable text, which is a bit less efficient than some of the more specialized machine-to-machine protocols. But for public communication, that universality is just unmatched.
All right, for our last section, let's pop the hood and look at what's underneath. All of these fancy patterns we've talked about, RPC, messaging, REST, they're all built on top of more fundamental, more basic building blocks. These are the raw tools of communication.
First up, you have sockets. And if REST is your user-friendly automatic car, then sockets are the manual transmission. They give you absolute, fine-grained control over every little detail of the network connection. This is amazing for high-performance, custom applications like online games or real-time chat servers. But it means you're responsible for everything, from managing the connections to figuring out how the data is structured. And if sockets are for talking between different machines, shared memory is for when processes on the very same machine need to talk to each other. It is the absolute fastest way to communicate, period, because you're basically just writing to and reading from the same little piece of computer memory. The big challenge? Making sure two processes don't try to write to the same spot at the same time and scramble the data.
So let's tie this all together in a nice little bow. RPC is your direct phone call for when you need a quick answer. Messaging is the postal service for reliable, decoupled systems. REST is the universal translator for anything talking on the public web. And sockets? That's your DIY toolkit for when you need to build something totally custom from the ground up. Each one is just a different style of conversation picked for a very specific job.
So, the next time you open an app and see your data just magically appear, take a second to think about the invisible conversation that just took place. Was it a direct, demanding phone call, or was it a patient little message dropped off at a digital post office? The secret language of software is all around us, and now you know how to listen in. Thanks for tuning in.